Starting. We're live. All right. Hi, folks. Welcome to the last live session for CSE110. I hope you guys have had a good semester and that you're sort of dealing with the finals and everything well. We've got just a few questions today, mostly related to sort of next steps to deal with programming and stuff like that, which we're more than happy to answer. And the first one is about what's the best way to take the programs we're writing out into the real world, right? So to make them sort of stand alone. This is a great question because it's a lot of times we don't actually teach this very much in our classes. We say, you know, we're doing everything in these development environments and you run the program by hitting the play button, which is not how anybody else in the world runs these programs. So with Java, it's actually pretty simple. If you've sort of seen a little bit under the hood about how Java works and how it's compiled, the code you're writing in these .java files is all just straight text, right? So you could open the simplest text editor you can think of, like Notepad on your computer, and you could write Java code. And then to actually make it compile, you would use the Java compiler, which you would have to go to a command line somewhere, and depending on what kind of operating system you use, it does different. It's different for how you do that specifically. To compile it, you would say Java C, you would type Java C, and then the file name, something like tic-tac-toe.java, and that would compile it to an executable, well, not an executable, to a class object, right? So this class object is executable with a special interpreter, which is the Java interpreter. So to run it, you would say Java tic-tac-toe.class, right? Or actually just say Java tic-tac-toe, and it knows enough to go looking for that specific class file and execute it, right? Now, if you want it to stand alone, you have to make it what's called a jar file, a Java archive file. And there's yet another command called jar that allows you to do that. And that command would be jar, J-A-R, CVF, Jar space, CVF space, tic-tac-toe.jar. That's the Java archive you want to make. And then tic-tac-toe.class. And that would be how you create a jar file. And that jar file you can take to any computer that runs Java that already has the Java the what now?
Virtual machine?
Yeah, the Java virtual machine installed on it, which is almost every machine. Almost everybody has it already. And all you have to do is double click that little file and it'll spin up right away and your program appears and starts running just like that, right? And that's what makes it super portable, is it doesn't matter if you make that jar file on a Windows machine, if you take it to a Mac, if you take it to a Linux machine, if you take it and drop it onto your Android phone, you are likely to be able to run it directly, unless you're doing something fancy. But most cases, you're able to just run from there, right? For Python, it's a little bit different. How would you recommend?
Well, so Python is intended to be more of a scripting language. So you can write fully standalone executable applications in Python. And then there are similar programs like the Java compiler or the Java jar creator that will compile your Python into a standalone executable. But most of the time what we're doing when we build small applications in Python and we want to run them is we just invoke them with the Python command on the command line. So if you had a Python file that you created, you know, maybe a tic-tac-toe.py file, on the command line, you would just type Python space tic-tac-toe and hit enter, and it would run your tic-tac-toe program for you. And that's what you're probably going to do 85 to 90% of the time. And if you were doing something more sophisticated than that with Python, you would use another tool to encapsulate that into an executable, standalone executable.
Yeah, yeah. For Bubble Cats, you guys saw that challenge. When I gave it to my wife as our anniversary gift, I used a program called Py2exe. So I actually wrote that in Python using the Pygame framework. So all the graphics and stuff that you saw were actually generated by a program that I wrote, and I used Python to do it. But there's a library. It's actually a library. So I wrote a script that converts all of the files, all the animation, all the software, stuff like that, to an executable that I could then just send to her. I could post online, and all she had to do is double click it, and it opened it up. And what it really does is it wraps all that stuff up into a zip file with a Python interpreter. So it comes with its own sort of way of running itself. She didn't have to install anything. It just started running right off the bat, which is a little weird, but you know, that's a way of sharing your programs and making them portable in a much simpler way. And this is what we call packaging. So when we take and write a program, we're sort of developing it, and then if we want to package it for distribution, that's a whole other step. And like every time you've seen like an installer for a program or something like that, that's a step after development is completed, where you do some more development just to get it into something that is deployable across whatever systems you're going to be working with, or for people to use out in the world and stuff like that. Cool. Awesome. And then the next question is, what are your recommended steps to build on what we've learned here and continue to learn computer science? Do you recommend any other books or courses?
Step one, don't stop coding.
Yeah.
Keep programming. Look for opportunities in your personal life and maybe close friends and family and colleagues where you can practice your skills and build a little piece of software that will help somebody do what they do better, faster, more accurately. So that's step number one. Another possibility is a follow-up class. So any kind of a CS2 type class. So this is what we call a CS1 class, or a first semester introduction to computer science course. So a second semester course like ASU's CSE110x course would be a viable option. And then at this point, I would hope that most of our students are fairly well equipped to go out and online and find online tutorials and engage those and be able to understand the terminology and the concepts, interpret that, and start to apply that. So there's lots of opportunities there. I'm also a big fan of textbooks. There's two broad categories of textbooks when it comes to programming books. There's tutorial style books, and then there's reference style books. So for someone who's just coming out of a CS1 course, I would recommend a tutorial style book. So this is a book that's going to, much like our course, walk you through the major concepts of a programming language or a programming paradigm with lots of examples for you to try and build on those step by step. And so you would start page 1, chapter 1, and work your way through until you get to chapter 2, page 1, chapter 2, and so on. And then once you start to feel really comfortable with that, you're probably going to want to, if you've picked a language that you're really interested in, find a reference book for that language, which is going to be something that makes it really easy to look up indexically a particular feature of the language or some particular type of thing that you'd want to be able to do with that language, and it'll have a concise example of how to do that in that language. Those books tend not to be particularly useful for people who are still very new to this, because it's a terse, very short description of what's going on there. So the tutorial style books would be your next best step. But soon after that, I would, if you pick the programming language, I would find a reference style book on that as well.
Yeah, totally. The some specific areas that you could go towards that we didn't cover at all in this class really is stuff like data structures. And that's what our 205 class is. And to answer the next question that's in this list is where can you find the ASU 205 course? Online, you can't at this stage. So this CSE110 was our first development effort for programming online for GFA. We don't yet have a 205 class, and we're unclear on the status of that class as it is. We know that it's on the roadmap. We want to do all the first year classes eventually, but we don't know when that is going to be open. We do have a 205 on ground class, but in the meantime, look around online for classes that say things like object-oriented programming or data, something like that, data structures and algorithms, that sort of stuff. That's the next sort of level of taking what we know as fundamentals and developing programs that process lots of information and deal with lots of different types of situations, really the most common situations in programming. And that it's going to stretch your ability by practicing all of the concepts that we've sort of explored in this class, and then taking it sort of up in scale where you have to, deal with lots of information. We've only dealt with, maybe, I think the biggest one was our Verde Valley volleyball. No, Pepper's Pill Mill had maybe 100 data points in there at some point. Your data structures is how you deal with information efficiently when there's thousands or millions or even billions of records. How do you process that information efficiently? How do you do things with it? How do you get meaning out of it in a reasonable amount of time? So that's a really challenging next step. Personally, you might want to start developing skills with doing graphics or graphical user interfaces, so that instead of the console and just text, you can make things with buttons, and you can make things that draw stuff and all kinds of stuff like that. Look into some of those things, and that's different depending on the language. There's lots of opportunities for there, and that's something that's at this level it'd be really easy for you to self teach rather than having to go through a class or something like that. But to reiterate, I learn best when I have a goal in mind. So something like, I just want a project, I'm going to try and build something that does something useful for me. I will learn the most when I have a goal and I can figure out what I need to learn to actually meet that goal. Recently, I developed a tool that takes in all the descriptions for my senior capstone projects that have been proposed and builds a document out of them. It's written entirely in Python. It reads everything out of a spreadsheet and builds a Word document that then I can then get printed and bound, and I can hand out to my students. So I don't have to do any processing between the information that comes in through a Google form on a spreadsheet and it spits out to a Word document. And I learned a bunch about Python doing this. I learned how to use, what is it? It's Open, I think it's called Open Excel, which is a Python library for Excel. And then there's a Py2Doc, PyDoc, actually, it's PyDoc. And that helps me make Word documents. And there's all kinds of stuff like this, these little libraries that allow you to be more capable than you could possibly be as an individual programmer. That's how you really expand your capability, is really those libraries. The techniques are, right now you've got a bunch of the basic techniques. You can do a whole lot that makes you very, very powerful. Learn some libraries that help you sort of bridge the gap between what you know now and what can be useful in the future. And that can take you really, really far.
Pygame's a good example of that, right?
Yeah, totally. Pygame.
How much more difficult would it have been to develop that game without the Pygame library?
Oh man, it would have taken, so to give you some context, I probably spent about 3 months working on Bubble Cats, right? And you saw the video, it's not a fancy game. I think I worked on the code itself for about 2 weekends. It was about 16 to 20 hours of work, something like that. And the rest of that 3 months was me doing those terrible drawings and animations and stuff like that, and getting all that stuff out work. But if I had to build it from scratch, I would have probably, it would have been 3 months of work or more, maybe 6 months, because there was audio interfaces, there was the keyboard interfaces, there was drawing to the screen, there was opening image files and all kinds of stuff. All of that was built into the framework. All I had to say is open this image, go to this frame, and then loop through them, and I got something that animates, and it was fantastic, right? So those libraries can make you super powerful. Pygame is a great one. You should totally check it out. At this level, you might go back and look up how to write classes in Python. That'll sort of flesh it out. All the same concepts applies in Java, but you can write classes in Python too, and now you have all the tools. And once you know that, you can integrate with some of these Python libraries and make some really, really cool stuff very quickly, and really exercise your sort of programming muscles and get really capable really quickly. So that's a great one too. So that actually is the end of our questions, right? So you guys saw the email that I sent out yesterday on Monday, thanking you guys once again for a great semester. We want to reiterate that we had a freaking blast working with you guys. You were a fantastic, very patient group of students, and we couldn't be more proud of what you've accomplished in this class. And you've helped us learn a lot about programming and teaching programming, especially online. Yeah. Do you have anything else you want to say?
No, it's been fun. It's been challenging.
Yeah. Totally.
We learned as much as you did and possibly more.
Absolutely, absolutely. It's been a quite an experience for us, and we were super excited to work with all of you guys, and we're excited to see what you produce. So you guys can, if you want to like keep in touch or like you know, show us what you guys are doing out in the world. You can find us by searching. If you go to asu.edu and search on the website for Phil Miller and Ryan Muth. You can find our email addresses and stuff like that, and you know, tell us what you're doing out in the world, and if this class helped or anything like that. And also fill out the course feedback stuff. We want to know what you thought of the class and how we can make more improvements to it.
Absolutely.
Yeah. Okay.
Cool.
Awesome. Thank you, guys.
Thanks, guys.